illustrated concept of cloud point in biodiesel and how it's determined using ASTM standard D2500. In low temperatures, biodiesel fuels can gel or crystallize, causing fuel filters to plug and fuel lines to clog, which can stop engines. During low temperature operation, petroleum-based diesel gels at low temperatures, some as low as -28 degrees Celsius, whereas biodiesel gels at warmer temperatures like these 400 times magnified coconut biodiesel crystals growing at 20 degrees Celsius. The cloud point is the temperature of the fuel at which small, solid crystals can be observed as the fuel cools. Feedstocks used to produce the biodiesel affect the cloud point temperature. Soybean oil feedstock produces a biodiesel that has a cloud point around 1 degree Celsius. Visible crystals show up in biodiesel made from canola oil around 0 degrees Celsius. Biodiesel made from jatropha oil begins to crystallize around 8 degrees Celsius. Palm oil with its high saturated palmitic acid content begins to cloud around 17 degrees Celsius. Biodiesel made from tallow and animal fat can cloud anywhere between 12 and 17 degrees Celsius. Impurities such as free glycerin and monoglycerides and feedstocks with a high fraction of saturates crystallize at higher temperatures and can serve as cloud seed, making the overall cloud point higher. Once the cloud seed is present, it is easy for other molecules to agglomerate because the molecules go to a lower state of free energy by doing so. This causes visible crystals to form a cloudy appearance. Here it is showing the visible cloud point in biodiesels of various feedstocks. Blending biodiesel with petroleum diesel and using cold flow additives can improve or reduce the cloud point by inhibiting crystal growth by shielding chemical forces. This is the standard testing method for cloud point of petroleum products. Please refer to the ASTM D2500 before performing test. Bring sample above 14 degrees centigrade above expected cloud point. Remove any moisture present by a method such as filtration through a dry lintless filter paper until the oil is perfectly clear as stated in the standard. Remove any moisture from testing device. Pour the sample into the test jar to the level mark. Close the test jar tightly by the cork carrying the test thermometer. Ensure the thermometer bulb is resting on the bottom of the test jar as stated in the standard. Place cork disc in the bottom of the jacket. Place the gasket around the test jar 25 mm from the bottom. Place jacket and disc 10 minutes prior to inserting test jar. Maintain the temperature of the cooling bath at 0 plus or minus 1.5 degrees centigrade. This table shows bath and sample temperature ranges. Insert the test jar into the jacket. Never place a jar directly into the cooling medium. At each test thermometer reading that is a multiple of 1 degree centigrade. Remove the test jar from the jacket quickly but without disturbing the specimen. Inspect for cloud and replace in the jacket. If the oil does not show a cloud at 9 degrees centigrade, transfer the test jar to a jacket in a second bath maintained at -18 plus or minus 1.5 degrees centigrade. Report the cloud point to the nearest 1 degree centigrade at which any cloud is observed at the bottom of the test jar, which is confirmed by continued cooling.
Visit our website at www.biodeaseleducation.org for more information. The Biodiesel Education Program is sponsored in part by a USDA grant.